Now let us discuss some examples of maximum power transfer theorem. So here the question is determine the maximum power delivered to the load in the circuit shown in this particular figure. So this is 100 ampere current source, 8 ohm, 6 ohm, 2 ohm, 4 ohm, and here it is RL is connected. Now what we are supposed to do is in maximum power transfer theorem, always remember first of all we have to apply Thevenin's theorem. So we have to find out first of all Thevenin's voltage VTH across open circuited load terminals. So wherever we are going to connect the load, so this is your VTH. We want to find Thevenin's resistance RTH while looking into the open circuited load terminals and removing internal independent sources. So from this side we are going to calculate the equivalent resistance RTH. Replace network by Thevenin's equivalent circuit and then find maximum power transferred at RL is equal to RTH. That is PL max is equal to VTH square divided by 4 RL or VTH square divided by 4 RTH. Now for this purpose, this here is the current source. So while calculating equivalent resistance and respectively the voltage, first of all we are going to open circuit this current source. So 8 ohm, 6 ohm, 2 ohm and 2 ohm. So here we can calculate the equivalent resistance looking into this terminal. And as far as we want to find out voltage across this 4 ohm, so if I coming is 100, then that into 6, this is total 4 plus 2, 6, 6 plus 2 plus 4. So 6 plus 2 plus 4, this will be denominator, and we want to find out current towards this or in this particular. So therefore in the numerator other resistor will appear, that is 6, and rest of 6 plus 2 plus 4, and this will be what we want to calculate, that will become 50 ampere. Now the voltage across 4 ohm will be 50 ampere multiplied by 4, so that is nothing but your RTH. So here this is current source, current coming here 100 ampere, and then it is going to get splitted. Okay. Now the next step is Thevenin's impedance RTH. So when we open this, then here the equation will be 4 parallel 2 plus 6. This is 4 ohm parallel 2 plus 6, because we are going to look into this term towards this. Now this is open circuit, so this is removed. So 2 plus 6, and then that will become parallel with 4. See here RTH how it is. You need not have to worry about this 8 ohm. It is to be ignored. Why? Because here we are going to do the open circuit because there is a current source. If here would have been voltage source, then we will have to short that, and then we would have calculated. But now there is a current source. So current source is open. We have to open it. Therefore, this 8 ohm will become non-effective. It will not contribute in the equivalent resistance. And now the end point is this. So 6 and 2, they both these two will come in series, and whatever is the resultant, that will come in parallel with 4. So therefore 4 parallel 2 plus 6, that is 4 parallel 8, and it is coming out to be 2.67. So RL is nothing but for maximum power transfer RTH, and that is nothing but RS. So it is 2.67. PL max will be VTH square divided by 4 RL. So therefore 200 square divided by 4 into 2.67, and this answer comes out to be 3759.39. Okay. Now one more example just we will consider here. So this is find R to have maximum power transfer, also obtain amount of maximum power. So this is our R we want to find out, and the circuit is 2 ampere current source, 10 ohm, 5 ohm, 6 volt battery, 2 ohm and 10 volt battery. Okay. Now current source to voltage source, let us convert 2 ampere and 10 ohm. So 2 into 10, that is 20 volt voltage source in series with 10 ohm. This is 5 ohm in series with this 6 volt battery. This is 2 ohm, and here it is 10 ohm. Now if we apply here mesh equation, or where if we apply KVL, this will be minus 20. Now this battery will be plus 6, and this I will be 10 plus 5. So 10 plus 5, total 15 into I, and plus 2I, or otherwise you can write as 20 minus 15 into I minus 6 minus 2 into I. So that is also allowed, or minus 20, rest of all are positive. So either you can use, and you can write the equation that is equal to 0. So from this equation I is coming out to be 14 divided by 17. If you simplify this little bit, this is the answer. Now open circuit voltage will be equal to 10 plus, because this battery potential plus drop across this. So 14 by 17 into 2. 14 by 17 is a current flowing through this 2 ohm after this particular loop. So therefore VOC is coming out to be 11.65. VOC is drop across 2 ohm plus potential of this 10 volt battery. So resultant voltage. And now RTH, how we will calculate? This voltage source is to be shorted. This voltage source is to be shorted. So 10 and 5 in series, and this will be 15 parallel 2 ohm. So 15 into 2 divided by 15 plus 2. So it is 30 divided by 17. RTH is 1.76. And maximum power will be VTH square divided by 4R, that is equal to 11.65 bracket square divided by 4 into 1.76. That is coming out to be 19.22. Carefully see the example once again. This current source, first of all, we have converted into the voltage source. Then we have applied here simple KVL. From that we have calculated I, and with respect to that I drop across this 2 ohm and 10 volt battery plus that drop across 2 ohm is going to generate open circuit voltage across this XY. And for knowing, because in problem R we want to find out, R is nothing but RTH. So that is shorted this battery while calculating equivalent resistance. So 10 and 5 will be in series, and then that will be in parallel with 2, and that is nothing but RTH. That is our actual load, that is R, and this is power maximum.